Mashruq Alam, did you
Yes,
see
sir.
the example? The basic example, right?
Yes, sir.
Okay. How many rules you have used? Can you tell me how many rules?
So which rules?
How many rules you have used for go back in?
Oh,
I written down some rules, right?
yes, sir.
Can you
I don't
remember?
remember at this moment, actually.
Okay. Anyone? Shahadat?
Sir, three rules, sir.
Right. Very good. Three rules. So see if you can just follow my lecture, even if you uh, do not have time to see after the class, just be attendant in the class. At least the basic logical things you should be able to understand. So in the last class, we have covered, first we have covered 3.3, that was about UDP, right? Then just a little bit review. We have covered UDP and different properties of UDP, and also you have covered the header. There were 4 fields in the UDP header, and different examples of application layer protocols that used UDP. Then we have covered how UDP works as a transport layer protocol. We have covered the UDP segment header. And then we have started section 3.4, principles of reliable data transfer. And we have discussed the abstract idea about in a diagram where we have said that network layer is by default unreliable. So network layer gives unreliable services, and transport layer on top of network layer actually provides reliability using some methods. This is the basic idea, but having said that, we have also mentioned that other than transport layer, network data link layer can also provide reliability, although that is not mandatory, right? That is not mandatory, and it is complementary to the transport layer reliability. So if any data link layer provides reliability, that is better. If it does not provide reliability, then transport layer will actually cover that up. One more thing we have mentioned, and that is very important to understand how a particular protocol provides reliability, is to understand that in networking, by default, we say that 2 processes are communicating and both processes should reside in different physical machines. That means each machine has its own memory, different than the other. So that's why we can think about a curtain in the middle. So if I think about the host of sending machine, then we can assume it can only receive feedback from the receiver. It cannot see the memory status of the receiving machine. That is what we have described here. So when you think about the sender, you should think about only what you see at the sender. You cannot assume anything what you cannot see. Similarly, when you work for the receiver, you will only think about the packets received. You cannot see the condition of the sender's machine. So same thing we should keep in mind when we implement something. Then we have described some of the basic methods, just basic idea how these methods actually implement the reliable data transfer protocol for transport layer. But there are some common properties about any protocol that gives reliability that can be also in the data link layer. So in section 3.4, as we said, the protocols can also be implemented in data link layer as a data link layer protocol. And some of the properties will be common when we will read TCP, that is section 3.5. Some of the properties will be common, but basically this can be in the data link layer also. Another category we have divided, that is all the protocols can be of 2 categories. One is non-pipeline, one is pipeline. In non-pipeline, only one packet at a time can be sent, and after receiving the acknowledgement, only then the next packet can be sent. So it's basically one by one. So stop, send one packet, then stop and wait for the acknowledgement before sending the next packet. And we have also covered 4 possible situations. I'm not going through this now, but these 4 situations, if you understand each of these, then definitely for any protocol, you should understand any case data lost or acknowledgement lost or data not, no data lost, or data is not lost, acknowledgement is not lost, but acknowledgement comes after the timeout. And also you should remember there is a timeout connected to each packet sent. Why? That defines the time the sender will wait before the sender will assume data is lost, and after the timeout sender will retransmit the lost segment. So that is the 4 situations. And then we have said, okay, there are 5 pipeline protocols. In pipeline protocols, multiple packets can be sent at the parallelly or simultaneously without waiting for acknowledgement. How many packets we can send, that is defined by the window. We call this the window. And definitely pipeline will increase the utilization because we can send multiple packets in the same time frame. And go back N we have covered in the last class, and as I said, we have also learned about, that was 31st. Okay, so we have written down 3 rules. You can see here these 3 rules used for go back N example, where first rule says, first and second rule actually is for all out of order. Out of order means if one packet is lost, then for all the subsequent packets, receiver will discard. First thing, it will not store the packet out of order, and second thing, it will send the last in order acknowledgement. And after the timeout of the lost packet, it will not only transmit the lost packet, but along with the lost packet, it will transmit all the other packets that was discarded by the receiver. So these are the 3 rules we have used. So let us now, this example we have also covered. Like this, we said the packet 2 is lost, but in fact, multiple packets can be lost. So we have completed this like this way, and then this is represented by the 3rd rule. Now we have 3 rules we have implemented for go back N. Now let us do one example of go back N before we go to selective repeat. Okay, let me give you one example. That is, I am giving you the question in the message box. Okay, perform go back in where N equals to now 3. In our example, N was 4. That means 4 packets can be sent at any time. Now I am changing N, that is 3 packets can be sent at a time. And then packet 2 and packet 5 are lost during the transmission, and you have to show, okay, this is just the information. You can see we will use go back N. in value of N will be 3, and in our earlier example only 3rd package was lost. Now I have changed that packet 2 and packet 5 are lost. So if you start from 0, packet 0 first packet, then packet 2 will be packet 1. It does not matter. If you start from packet 1 as first packet, then packet 2 will be packet 2. So it's just indexing according to you, no problem. You can start from 0, you can start from 1. But 2 packets are lost. Now you have to draw the sequence diagram for how many packets. Show the sequence diagram.
Sir,
Yes.
sir, slide share any sir.
No, okay, no problem. Just I am giving you the question first in the message box. See your message box, okay? Show this, then I will share the slide again. Show the sequence diagram up to successful transmission of 6th packet. Now, did you get the question, everybody? Now I can share you the slide. Okay. So did you understand the question? Now, in this example, n was 4. In our question, n is 3. So 3 packets can be sent. After sending the 3rd packet, you have to wait. You can start from packet 0, like index can start from 0 or index can start from 1, no problem, anything. But when I say packet 2 is lost, then 2nd packet is lost. If you start from 0, 2nd packet is packet 1. If you start from 1, 2nd packet is packet 2. And also packet 5th packet is lost. So these 2 packets are lost, and you have to continue this sequence diagram until packet 6. So if you start from 0, packet 6 is packet 5. If you start from 1, packet 6 is packet 6, right? Until packet 6 is successfully received in the receiver. That means without any gap. Did you get the question? Everybody?
Yes, sir.
Yes, sir.
Okay. Now take your paper and pencil. At the end of the class, you have to upload your solution to the LMS. Keep in mind. But not this one. I will ask you which one to upload. But if you don't participate for this one, then the later one you will not understand. So everybody, please participate. Be careful. So do it in your paper and pencil. I am giving you 5 minutes for initial drawing, and then I will start the solution. You will just match the solution with me. Then in the later part, I will assign you another question. You have to draw the solution and you have to upload the solution to the LMS. If you have any question, you can ask me. Okay, everybody? You can take a snapshot by your smartphone or device, because I will stop the share just few minutes after, and then I will start sharing using my tab, okay, to give the solution. So just take a screenshot here, or you can open your own PowerPoint slides. First few first few lines, I think very trivial. If you just follow this, you can, but try to understand first before you draw. and try to complete as much as possible, because even if you do error in your solution, when I will give the solution, that will be easier for you to understand what you have done wrong. If you don't do this, it will not be easy to understand. Okay, can I stop the share now?
Yes, sir.
Okay, I am stopping share here. And okay, 2 more minutes, and then I will start. Try to complete as much as you can, even if you are not sure, even if uh, you make a mistake, no problem. Try to complete as much as possible until okay, let me start with the solution. You can just match with me. In case of any kind of confusion, please feel free to ask. So what I am showing here, see, I am drawing the window on the left side. So I don't need to uh, write down all the packets. I will write down only the packets specified by the window. So initially, what will be the window? 0, 1, 2, right? If I start from 0, we can actually start from 1 also. Okay, let me do one more thing, I think, to make it sure that you can start from anywhere. So this is actually window, and window equals to n equals to 3. So what I am doing, I will start from 1. It is not a problem. I can start from 0, I can start from 1. So initially the window will be 1, 2, 3, and it will continue to be 1, 2, 3 for the first 3 packets, right? So packet 1 is sent, then packet 2 is lost, and packet 3 is actually sent. So I can say this is packet 1, this is packet 2, this is packet 3. Then you must say you have to wait, right? Any question up to this point? Anybody?
No, sir.
Okay. Please ask me, because in the next part, when I assign you, then I will not give you the solution. You have to do it yourself, and then you have to upload in the LMS. Okay, so
Sir, I have a question.
yes.
Sir, if
Yes.
we start from 0, sir, then what will be the lost package? Number
Packet
of
1.
lost package, sir?
Packet 1. That means second
Exactly,
and
sir.
fourth, fifth packet lost. That means in your sequence. So if you start from 0, packet 1 and packet 4 will be lost. If you start from 1, packet 2 and packet 5 will be lost. Clear? No confusion.
Okay, sir. When it will be the gapping part, then it will lost, and then it will also send, sir.
Right, right. Okay, so since packet 2 is lost, what you can do, you can just set a timeout, because the timeout is not set after. The timeout is set whenever a packet is being sent. We are not showing timeout for packet 1 and packet 3 because those are not lost. So we are assuming that the acknowledgement should come within the timeout. That's why we are not showing. But every packet has a corresponding timeout. So to make the diagram more and more clear, we will only show the timeout for those packets those are lost. Clear, everyone? And you can initially, it doesn't matter what is the size of the timeout you have given. Your answer will be correct if you follow the rules. Okay, so for our case, I have just set a timeout. This is for timeout for packet 2. Okay, this is timeout for packet 2. Then when packet 3 is sent, see, the sender must wait. Then when sender will do some task again, anybody? Okay, let me ask Khalid Ridwan. Are you there? Khalid Ridwan Mubin. Shahariaz.
Yes, sir.
Shahariaz. Okay, can you tell me
Yes, sir.
when host A will do some task again? When? Because it has sent 3
Sorry,
packets,
sir.
now it has to wait.
I am trying to understand, sir.
Okay. Okay, no problem. Tahmina? Tahmina Tanjin, are you there? No? Muhammad Mahfuzur Rahman?
Yes, sir.
Mahfuz, can you tell me when host A will do something again? Because it is waiting now. Waiting for what?
Sir, still, sir. Sorry.
You have to have some understanding. See, otherwise it will be a problem, because I have covered this entire thing last class. You have to understand the something at least. Okay, you can give me wrong answer, no problem. I will never ever be rude on you if you answer wrong. But I like you to participate, because these are things very simple if you understand the concept, very complex if you don't understand the concept. There is no middle. You cannot see a solution, you understand the concept. It is very tough for this type of question. You understand the concept first, then the solution will be easy. Okay. Fazila,
Yes, sir.
can you tell me
Sir, I have two
when?
things. Sir, I
Okay,
think
no problem.
packet 1 and packet 3 will receive the acknowledgement, or we have to put the packet 4, it will receive the acknowledgement, it will be like n equals to 3. Like I have to solve.
Okay, you are correct. You are correct. First thing I wanted to know actually is acknowledgement. Acknowledgement. Okay.
Yes, sir.
So whenever it receives an acknowledgement, then it will act again. Until an acknowledgement is received, host A will be waiting. Okay. So the answer is, whenever host A will receive an acknowledgement, it will again do a particular action. That is the answer. Everybody, Shahariaz, Mahfuz, can you get my point? Okay, now to understand this, what we will do, since before receiving any acknowledgement from the receiver, sender cannot do anything. So now after completing this part on behalf of sender, now you go to the receiver end. As I said, don't think about both sides simultaneously, just think about one side at a time. So you have completed the part of host A, then you go back to host B as the receiver. So what host B will do? First, you have to say it will receive packet 1, so it will send acknowledgement 1. That means it will send acknowledgement. Now, where this acknowledgement will be received, it's up to you. Anywhere in the age line, you can put the acknowledgement, but you should have should be just reasonable. For example, you should not put the acknowledgement of P1 before the packet P2, right? Is it understandable? Because P1, P2, P3 is sent almost simultaneously in a very small amount of time. And acknowledgement 1 is sent by the receiver B after it received packet 1. Definitely the time difference will be a little bit more, right? So that is the logic. There are two different machines. So suppose I have put the acknowledgement 1 here. Now packet 2 is not received by the receiver. No way to send the acknowledgement. Right? Now packet 3 is received. Is packet 3 out of order? Just wait. Just wait. Ashrafun Nahar. Ashrafun Nahar, are you there?
Yes, sir.
Can you tell me, is packet 3 out of order or in order? What is mean by out of order? For the receiver's perspective. Is it out of order? Yes or no? No idea?
Sir, packet 3.
Yes. When packet 3 is received by receiver B, is it out of order? Because we have written all the rules for out of order packets, right? All three
Yes,
rules.
sir.
So is it out of order? Yes or no?
Sir, I'm confused, but I guess it's not.
It's not. Okay. Shifa Chaudhuri.
Yes,
Shifa,
sir.
is it out of order or in order? What is mean by out of order? Can you tell me? See, out of order means what? If you don't receive packet 2, you receive packet 3. Is it in order or out of order? Very simple.
Out of order.
Yes, it's out of order, but you have still confusion. I can understand.
packet
No
3
confusion. Whenever you
order.
receive out of sequence, that means you received 1, 2, then you received 4. Where is 3? So that is out of sequence, right? Out
Yes,
of
yes, sir.
sequence is out of order. So this is actually out of order. Clear?
Yes, sir.
Okay, Misbahul. Misbahul, are you there? No? Yasir Arafat?
Yes, sir.
Yasir, can you tell me what the receiver will do? Because as Shifa said, as I said, packet 3 will be out of order. Why? Because it did not receive packet 2. So packet 1, then it will receive packet 3. That means it is out of order. But then what receiver will do? What about the first rule of go backend? What receiver will do? Can you tell me? No idea?
Sir,
Receiver can do two things. Receiver can store the packet as it is, send an acknowledgement, or receiver can what? Discard the packet, right?
sir, here discard the packet. Maybe.
So it will discard the packet. Why discard?
Because
Can you tell me the reason?
there are some packet missing.
Right. So it is out of order. So that's why it will discard the packet. Good. So it will discard the packet. It is a very simple logic. In go backend, if it receives a segment out of order, any segment out of order, that means some segment missing in the middle, for all the subsequent segments, see, we have written down the rule. What was the rule? So here it will apply the rule. For example, let me write down packet 3 is received, and we can say packet 3 is out of order, right? Because packet 2 is missing. So what receiver will do? Discard. So that is what? That is our rule number 1, right? Sudhir,
Yes, sir.
can you tell me what is rule number 2? What is specified in rule number 2? After discarding the packet, what B will do? Did you write down the rule number 2? You have the rule number 2 in front.
No, sir.
No, why? Because you should take some notes. Abdul Rahim. Rahim,
Yes, sir.
can you tell me what receiver B will do after discarding?
Sorry, sir, I didn't attend the last class.
Oh, you did it. Was not, but you were present in the last class, right?
First time I was present, sir.
At least in the class, you should understand something so that you can try to answer. That is my point. Your answer may be wrong. You may be okay. Rule 2.
Sir, I was disconnected after 10 or 15 minutes.
Okay. In that case, just at least there was a weekend, right? Just at least
Sir, that's my mistake, sir.
one time. Okay, fine. Miraj Farooq. Miraj. See, I will not call these roles again. So be careful. Abu Abdullah. Khondokar Shravan. Shah Alam. Imtiaz Hussain. Rifaz Nahian.
Yes, sir.
Rifaz. Okay, Rifaz. Can you tell me what receiver B will do now? It will apply rule 2. Simple. First thing you can say it will apply rule 2. But what is specified in rule 2? What is specified in rule 2?
Sir, I will
About
have to
acknowledgement.
see from the slide, sir. I was not present in the last class.
Oh, that is the problem.
Yes, sir.
Okay, in that case, let me go to Kamrul Islam. Kamrul, Dihan Pathan, Abu Kibriya.
Sir,
Dihan, are you there?
Satyan Pathan.
Okay.
Yes, sir.
Were you present in the last class? I see
Sir, I was present,
present. You are present, but you have no idea. See, maximum of you are not being.
confused, sir.
You can give an answer. Even if you are confused, you can at least give some answer related to the question. It must be relevant, but your answer can be wrong. What I tried to actually do, I tried to participate you in the class. I'm not very rude if you answer wrong. I'm saying many times, but
Sir,
I'm
may I
giving.
try?
Yes, Rifas.
Sir, since it has missed the packet 2,
Right.
it might send a duplicate packet back to the sender.
Duplicate. You're close, but duplicate, not duplicate
Can I
packet.
answer this? I think I have.
Okay, which one? Mashuke?
Mashukalum? Yes,
Yes,
Mashukalum.
yes,
I
Mashukalum,
think,
yeah.
I think as it missed the packet 2, if the P3, then receiver will send the acknowledgement for packet 2. Like it will again ask for packet 2.
Just a little bit gap here. Packet 2 is not received at all, right?
Yes, sir.
Packet 2 is,
So
receiver has
when
no input in packet 2. So you can relate to packet 1 actually. Last received packet in order.
Yes, sir.
Okay. So what it will send actually packet acknowledgement 1. Okay. So we can
Actually, previous acknowledgement after before lost package.
Right, is that good? Yes, previous we say it in order. In order means if you say previous, there can be 3 acknowledgements previous, right? All are previous, but it should send the last in order.
Yes, sir.
In our
The last
case,
in
there
order
is only
is
one
in
acknowledgement,
order.
only one. Last in order, yes. So if there are 3 acknowledgements, it will send the latest one. But in this case, there is only one acknowledgement, so it will resend. You can write like this: resend.
Yes, sir. Resend acknowledgement.
1, right? Acknowledgement 1. So this is actually rule number 2, right? Everybody, I am taking so much time. Why? So that you have time to understand. If you understand one step like this, you are understanding almost 70%. Any question from anybody, we have already applied 2 rules, only 1 rule left. Any question? Okay, now this A1 will be sent to host A. Acknowledgement 1 will be sent. Now see what receiver will do now. What receiver will do? Nothing to do, right? So receiver's part is again completed until sender sends a new packet. So in this time, you just keep receiver's side as it is, come back to the sender side. Now, in the last case for the sender side, we have finished up to a timeout, right? Now there are 2 more acknowledgement receiver. Whenever an acknowledgement is received by the sender, it will do some action. What will be the action? The first action will be what? The first action, if it receives an in order acknowledgement. Yes, Ishtiaq, what will be the action? Possible action?
Sir, it will again send the in order package.
Next packet.
That means the next packet.
Very good, very good. But before that, to make us understand better, we can also think about, since it received an in order acknowledgement, the window will move, right?
Yes, sir. One step move, sir.
Right, 1 step move. So that means what? That means window is now saying host A that you can send packet 4 now. When? Just after receiving acknowledgement 1 in order. So it will send packet, next packet here. Send the next packet. Okay. Okay. Now, after receiving the duplicate acknowledgement, what will happen? Which packet will be sent now? Now it's open.
Sir,
Anybody? No,
Sir,
just
now,
after receiving the duplicate acknowledgement 1, what
It will
sender
again
will do?
send the
sir, it
acknowledgement
will
for 1.
again discard the packet, sir.
It will resend acknowledgement 1.
I will send the acknowledgement one
Acknowledgement is
again, sir.
already sent by the receiver. Acknowledgement 1 is already sent by the receiver. Sender will not send acknowledgement any time. Sender will only send new packet. Right?
It will send P2.
P2, P3, P4.
Yes, sir. P2, P3, P4.
But timeout is not yet done. We have
Timeout, sir.
rule 3 after the
Sir,
timeout.
So it will wait.
Resend the packet, sir.
It will wait for
Wait.
timeout. And then
Right,
send
wait
P2.
for timeout. That's
And then
good.
send.
Okay, before wait for timeout, you have to make it more clear. First thing, whenever an acknowledgement is received, host sender will do some action, but action can be no action if it is a duplicate acknowledgement. So what it says in our example also, you can see here, this is ignore. Can you remember? Ignore duplicate acknowledgement 1. Ignore means it will do nothing. So the window will be as it is. There will be no packet sent. That means it will do nothing because this is a duplicate acknowledgement. So you have to keep in mind. Now
Sir,
what will be the next event? Yes.
Sir, now, sir, from P4 to the receiver, sir, then what will be the action of receiver, sir, right now?
Because we are at the sender now. That is what I have asked you. Don't I think do both sides at the same time. Either
Yes, sir.
sender or receiver. So if we are at the sender now, we have completed the receiver part, then we can come back to the sender side. Now after completing the sender side, then we will go back to the receiver side again. Now we are at the sender side. So don't think about receiver side now. You have to complete the sender side.
Okay, sir.
But to complete the sender side, see, the next event will be after the timeout, right?
স্যার
Yes.
স্যার পকেট 3 এর ক্ষেত্রে আমরা অ্যাকনলেজমেন্টকে রিসেন্ড করতেছি কেন?
That is rule. You have to understand the rule first. A plus b whole square equals to a square plus 2ab plus b square. Why is that? Because that is the rule. So
Yes.
we have covered the rules first. Go back to the rules, and every rule has a corresponding logic. I have already specified the logic, because if it receives out of order segment, it will discard, and then it will resend acknowledgement 1. Those are rule 2. Right? Clear?
Yes. Yes, sir.
So now the next question is when it will retransmit after the timeout. And then there is rule 3. What rule 3 says? After the timeout, retransmit lost one along with the ones discarded. So packet 3 was discarded. So after packet 4 will be also discarded. Okay, let me finish the receiving end first, so it will be more understand after coming back to timeout, because there is only again one packet sent to the receiver. So let us finish the receiver part. Receiver received packet 4, again it is out of order, right?
Yes, sir.
Yes, sir.
So it will discard. I am not writing everything now, but this is rule 1, and it will resend acknowledgement. So again it is applying rule number 1 and 2. Sorry, acknowledgement 1. It is again acknowledgement will never change until a new lost packet is retransmitted. So now you have completed this part. Maybe it came here, for example. It doesn't matter where you put the acknowledgement, it depends on the time. So after the timeout, then rule 3 will be applied. Now see, 2 will be retransmitted definitely after the timeout, but since packet 3 and packet 4 was also discarded, so what will happen? Packet 2 will be retransmitted, packet 3 will be retransmitted, and packet 4 will be retransmitted, right? Is it clear? And this is actually what? This is rule number 3, right?
Yes, sir.
Yes, sir.
Just you have to keep those 3 rules in front. Write down those 3 rules and keep an eye on that whenever you solve this. So every step you have to either apply rule 1 or rule 2 or rule 3 or normal operation. If there is no loss, normal operation, no rule is needed. Okay. So now see, again you have finished the receiver part, sender part. Go back to the receiver end. Now complete each one. So it is what? Packet 2, right? Now it is in order or out of order?
In order,
In
sir.
order, sir.
In order. So normal operation. It will
So
not
it will
be
send
accurate
back
4.
to
Acknowledgement
2.
2, right?
Yes, sir.
Then after receiving packet 3, then acknowledgement
3.
3. After receiving packet 4, acknowledgement 4. So normal operation. Now you can point out these acknowledgements here, and then you should continue. Okay. Now what will be the next action? Now I have to come back to the sender side because receiver side is again finished. So when you come back to the sender side, then acknowledgement 1 for this one, again this should be what? Ignore, duplicate, acknowledgement 1, right? Is it clear?
Yes, sir.
Then after receiving acknowledgement 2, you have to think now window will move. So previously I didn't write up the window because window never moved. But after receiving the acknowledgement 2, window will move what? 3, 4, 5, right? Is it clear?
Yes, sir.
That means what? That means you can transmit packet 5. After receiving acknowledgement 3, window will move 4, 5, 6, right? After receiving acknowledgement 4, window will be 5, 6, 7. Is everybody clear? Just window is updating if it receives an in order acknowledgement, and it indicates that you can send then packet 6 and you can then packet 7. We have to show how many packets? Up to 6.
Up
to 6, right? So keep in mind, although we have written down packet 7 here, it is not needed, but due to the rule, you just follow the rules. So I have written down packet 7 can be transmitted. Now transmit all, but as it said, packet 5 is?
So P5 will be lost.
No.
Also.
Yes. So whenever packet 5 is lost, just again set a timeout at your choice. Doesn't matter how long you have given the time. Timeout is not fixed. So anywhere you give the timeout, no problem. Your answer will be correct. But packet 5 is lost, but packet 6 is not lost, right? And packet 7 is not lost. Now the problem is sender side again finished. Now sender has to wait, right? You cannot do anything until another acknowledgement is received. So go back to the receiver side. Receiver side, then finish the receiver side. If it receives packet 6, is it out of order or in order?
Sir, out of order, sir.
Right? So out of order, that means it will discard. That means it will
resend the acknowledgement, sir.
Resend which acknowledgement? Can you tell me?
Sir, 4, sir. Acknowledgement 4, sir.
Very good. Acknowledgement 4. So see, every time a rule is applicable, we apply the rule. Okay. This is rule 1. This is rule 2. Again, we applied for packet 7. Is it out of order?
Yes.
Yes, right? So just you know.
Yes, sir. This is sir.
Right. So packet 5 is missing. Until packet 5 is retransmitted, all subsequent packets will be discarded, and the previous last in order acknowledgement will be sent. Now see, the receiver part is complete. Again, come back to the before coming back, you have to send this here, somewhere here. Okay, both the acknowledgement, but again these acknowledgements are duplicate, so it will do nothing. Window will not move, right? Okay. Yes, can anyone tell me what will be the window after receiving these this acknowledgement? After receiving these acknowledgement, what will be the value of window?
Sir, it will remain same.
sir.
Very good, very good. See, many of you already understood the thing, because this is very simple, very logical. You have to think, you have to connect to your thinking. So out of order, discard, you received duplicate acknowledgement. That means window will not move. That means you cannot send a new packet. Okay. Now after the timeout, what will happen?
Sir, one step
Packet
will be
5,
forwarded.
packet 6, and packet
6 and
7.
packet 7 will be same, sir.
Will be retransmitted.
Right, will be retransmitted, and this time no packet will be lost, because packet 5 was already lost once, retransmitted. And then you don't need to complete this part. You can, it's like this way. And in this point, when you have to complete this part, packet 5, then acknowledgement 5, packet 6, then acknowledgement 6, packet 7, then acknowledgement 7, right? Although we need up to packet 6, but according to the flow, you have to show up to packet 7, acknowledgement 7. So this is the solution.
Sir, can you please summarize all of this one time?
Actually, there is no shortcut to summarize. You have to do it yourself.
Just read the solution
apply.
one time.
Okay, apply. Just follow normal procedure. If a packet is lost, apply rules. That is the simplest thing. And one more thing I said, just complete the sender's part, then go to receiver's part, then come back to sender's part, then go to receiver's part, like this. Don't do simultaneously both ends. Then you will be more and more confused. Although if you understand, maybe your confusion will be very less. But if you follow this procedure, do part by part, and just keep in mind the rules and logic, not only the rules, the logic, then it should be, maybe you have 10 answers by 10 students, all 10 answers can be correct, as long as you don't violate the rules. Is it clear? Any question? Okay, now.
Sir.
Yes.
What if you lost the first packet?
Okay, no problem. If you lost the first packet, that means there will be a timeout, right?
Yes,
and then if you receive packet 2, packet 3, no problem. Since, okay, now let me clear one thing.
Then receiver will know
receiver will know that, because there is a connection establishment. Okay, any reliability protocol must have a connection establishment. So receiver should know from where it should start receiving. Okay, so it will know that. Okay, I will start receiving packet 0 or packet 1. But if first packet is lost, second is received, then it will clearly understand I did not receive the first one, because I should start receiving from packet 0 or packet 1. Okay.
So then which acknowledgement will it resend?
Very good question. In that case, actually it will discard and it will not send any acknowledgement. Okay. Because there was no previous acknowledgement. Simple. So a little bit exceptional, but receiver will understand that I did not receive the first one. When you read the connection establishment in chapter 3, I think later on, for TCP connection establishment, it will be more and more clear, because in the connection establishment, these things are set between A and B. So anyways, this is go back and now if we just understand go back and, it is very easy. It will take 2 or 3 minutes to understand selective repeat. Why? Because see, in go back and it is very inefficient. Why very inefficient? Because the correctly received packets not stored, right?
Yes, sir.
If it could store, then we don't need the repeating those packets. Only we just send the lost one. So this is the idea of selective repeat. See the name, selective repeat. Go back in, go back in. Like if you lost packet 2, go back to packet 2. Selective repeat. Just if you lose some packets, then just retransmit only that selected packet. So that is the idea of selective repeat. Now, if you want to understand the selective repeat, just you need to write down these rules for selective repeat, the same logic will apply, just with the approach of selective repeat. As I said, it will send only the lost packet. So if I write down the rules, selective repeat, so there will be 3 rules. First one, buffer. So instead of
Sir, we can see your screen right now.
Sorry?
Sir, are you writing something?
Yes. Oh, you're not seeing?
Sir, but
Oh,
sir.
okay, just 1 minute. Okay, I have to stop presenting here, and then I have to present here again. Okay. So see, just I am writing the same 3 rules for selective repeat. I am just changing the word. So previously it was discard, right? Selective repeat will not discard the out of order package. It will buffer. Buffer means it will create a gap. It will store a gap for the lost packet and then store the received packets later. So there will be a gap. Okay. But it will not discard. It will buffer. It will store the out of order packets. Clear? Then earlier we said send last in order acknowledgement. In this case, we'll send individual acknowledgements. Okay, for all out of order. Individual means if packet 2 is lost, if it receives packet 3, since it stores packet 3, it will send acknowledgement 3. Okay, and then retransmit only the lost packet, right? After is it clear?
Yes, sir.
Just simple change. Idea is selective repeat will be much more efficient in terms of memory utilization and bandwidth utilization because it will not discard the packets received correctly even if out of order. So that is the idea. Now let us go back to our example. Okay, so sorry. So where the changes will happen, if we just redraw the same thing, can I duplicate this? Okay. Okay, let me do it in a new page so that you will understand. But before that, what I will try to do, where the changes will be. So here see rule 1 and rule 2 applying discard and resend. This will be now, even if out of order, this will buffer. So this will be buffer. And then there will be no resend. It will be sent acknowledgement 3. Okay, here, like here, it will be sending acknowledgement 3. For packet 4, it will not discard, it will buffer, and it will send acknowledgement 4. Got the idea? And for rule 3, here, it will send only packet 2 instead of packet 3 and 4. So that is the idea. Now, if I do the same thing,
Sir, the sender will resend packet 2 after the timeout.
right?
Or-
Definitely,
Okay, sir.
definitely after the time. The only way sender to know that the packet is really lost is the timeout. There is no other way. Okay.
So, sir, it
So-
will send the missed packet and then the other new packets also, right?
No, other new packets is previously sent as out of order, but it is not discarded by the selective repeat. It is stored. Okay, let me just give the solution,
Yes,
then it will be
let us see.
clear. So selective repeat. Now again, it will be n equals to 3. It will be packet 2 and packet 5 lost, and it will be show up to 6th packet. So the same question, but now instead of go back and we will use selective repeat. So what we will do, host A and then host B, and what initially it will be 1 2 3 1 2 3 1 2 3, same. Now it will send packet 1, packet 2, packet 3, and packet 1 is received, packet 2 is lost, and packet 3 is received by the receiver, and then sender must wait. So this is the same. And since packet 2 is lost, let me set a timeout for packet 2, same as previous one. Now go back to the receiving end, and packet 1 is received, acknowledgement 1 is sent. Now when packet 3 is received, this is out of order, right? But
sir.
what the rule says,
So discard
no
buffer.
discard, buffer. This is
Right
selective
now it will be
repeat,
buffer. Okay, sir.
Now let
You
me
can
show one thing.
one.
Let me show one thing. This is packet 1, right? Then packet 2 is lost, right? Then packet 3 is received. So what it can do, previously go back and discard it. But selective repeat will keep a gap here, right? Keep a gap here, and then store packet 3 here, store packet 4 here, like this. So whenever packet 2 is retransmitted, it will clear the gap. Clear concept?
Yes, sir.
Okay.
Yes, sir.
So send it will send now acknowledgement 3, not the acknowledgement 1. It will send individual acknowledgement. Receiving part complete. So selectivity is much easier to draw. Much easier to draw. Okay. So suppose those acknowledgements will come here. Now after receiving acknowledgement 1 as previous, it will be 2 3 4, and then sender will send packet 4, the next packet, and then packet 4 will be sent to the receiver. After receiving acknowledgement 3, what it will do? Can it send packet 5?
Yes, sir, it can.
No,
But
because
oh no,
window
sir,
will
because
not,
it's waiting
window
for.
will not permit. See, so that is the importance of window. Window will not permit you to transfer. So
So
that's
উইন্ডোটা
why
কি consecutive 3টা করেই থাকবে সব সময়?
definitely window is like you are using array, and you are saying you cannot transmit more than 3 at a time. So what you will do, you have to keep pointer, right? You have
Yes,
to
sir.
keep pointer from which memory location to which memory location I can process. And if only I have completely received the acknowledgement from the other side, only then I can forward. So if
Okay,
it
sir.
says acknowledgement 3, window cannot be changed because window must be consecutive. If 2, there is a gap in 2, you cannot move window. So even if 3 is received, there is a gap with 2 because 2's acknowledgement is not received, so window cannot move. And
Okay,
same
sir.
thing here, ignore now, not duplicate. There is no duplicate acknowledgement, but there is a out of order acknowledgement. A3 is out of order acknowledgement for sender, right? Is it logical?
Yes, sir. Yes, sir.
Right. So it will not send a new. And also, if you understand using window, that will be much more clear. Window will not permit to send packet 5, although there is a new acknowledgement received. So then the send packet P4, sender, it will be again out of order, but receiver will buffer, and receiver will send acknowledgement 4, right? And then acknowledgement 4 may be coming somewhere here. You can write down anywhere. Now after the timeout, what will happen? Only packet 2 will be retransmitted, right?
Yes, sir.
Okay, and this time packet 2 will not lost, because packet 2 will be lost for the first time. Second time it will not be lost, and this is actually our rule number 3 for selective repeat. So this is our rule number 1 for selective repeat, and this is our rule number 2 for selective repeat. Is it clear now? So see, selective repeat is much easier to draw. Now we will again complete the receiving part. It received packet 2. So what it will do? Definitely it will send acknowledgement 2. Now it will not say buffer, because it is a normal procedure. It will fill the gap. So if out of order, then it will buffer somewhere, and then with the gap it will store after the gap. If it receives packet 2, normal procedure, send acknowledgement 2. Now after receiving the acknowledgement 2, what will be the window?
5, 6, and 7.
So one step forward.
Very good, Rufus. 5, 6, and 7, because 3 and 4 acknowledgement was previously received, but only 2 was not received. That's why window could not move. Now when 2's acknowledgement is received, 3 and 4 previously received, so window can be moved 3 places at the same time. So that is the idea. That is where selectivity is much better, because now user can send 5, 6, 7, right? 5, 6. So window will move at a time 3 places. And then, but before acknowledgement 2 is received, window did not move. That's why before receiving acknowledgement 2, you cannot send a new packet. But after receiving acknowledgement 2, now packet 5, packet 6, and packet 7 can be sent, right? And as previous cases, packet 5 will be lost, packet 6 will be gone, and packet 7 will be gone. And since packet 5 is lost, let us set a timeout for packet 5. Okay, then continue to finish. Now go back to the receiving end. Receiver received P6. Is it out of order or in order?
Out of order.
It's out of order.
So again, like rule 1 applied, buffered, and then acknowledgement will be acknowledgement 6. Packet 7 out of order, buffered, rule will be acknowledgement will be acknowledgement 7. Now just put maybe here, maybe someone here, and then after the timeout only, sender will send packet 5 again, and this packet 5 will be received by the receiver. Acknowledgement doesn't matter. This is packet 5 received. Acknowledgement will be acknowledgement 5. Since packet 6 was received earlier and buffered, so this is end of our solution, right?
Yes, sir.
Is it clear, everybody?
Yes, sir.
Any question? So see, this is the solution. Okay, now we have 15 more minutes. See, I have given you the clear solution. Now I am just changing a little bit. Let me. Did you draw in your khata? Because I will close this now. I will give you an assignment now. Same thing, just with different values, and and then stop presenting here. Let me start presenting here again, and okay. Okay, you have to do now. Okay, you have to do solve using both go back in and selective repeat for. Same thing, packet 3 and packet 6 missing. N equals to 5, packet 3 and packet 6 missing, show up to 7th packet successfully received. Okay, so this is the question. Do it in a blank page, 1 or 2 blank pages, then you have to
So we have to show
scan
two simulations, one for go back and one for
right
selective.
right selective will take very less time. First do it go back and n equals to now 5, and now packet 3 means if you start from 0, packet 2 will be lost and packet 5 will be lost. If you start from 1, no problem, then third packet and sixth packet will be lost. Yes,
sir, that means you have to now consider 5 packets together, right, sir?
Window, in the window at a time you can split 5 packets.
Yes, sir. Yes, sir. Yes, sir. Yeah.
Okay, we have more than 12 minutes. I think it will not take very much. Just complete and then upload in the ELMS. I am creating a link, okay? I am creating a link in the Can I remove the share? Please write down the question. I will remove the share and I will create a link in the ELMS. Don't worry, if your answer is a little bit problem, if I give the solution, then you can match. But whatever you understand, do it yourself. Abu Kibriya, are you there? Bidhan Chandro, Shakhawat Hussain,
Yes, sir.
Bidhan. Okay, Bidhan present. Shakhawat. Khondokar Jahidul Islam,
Yes, sir.
Abir Reza, Amanta
Present,
Hussain.
sir. Abhiraj present, sir.
Okay, okay. Amanta,
Present, sir.
Shafiqul Islam,
Yes, sir.
Mahfuzur Rahman Sifat,
Yes, sir.
Abdullah Al Mufail, absent. Abrar Sadiq,
Present, sir. Sir.
okay. Abrar Sadiq present. Sabbir Sarkar,
Sir,
Yes,
present.
sir.
Abdullah Mufail also.
oh, Mufail, okay. Mashuke Alam present. Shakib Hussain,
Yes.
Shakib, are you there? Okay, Shakib present. Tanvir Hassan,
Sir, chat box selection.
okay.
Yes, sir.
Okay, Al Shahriar,
Yes, sir.
okay. Rakibul Islam,
স্যার রাকিবুল ইসলামের স্যার একটু নেটে সমস্যা বললো।
okay. Okay. You are present in the class?
জি স্যার, ও ছিল কিছুক্ষণ পরে বললো।
Okay. Shahadat present. Taki Yasir,
Present, sir.
Adnan Kobir,
Present, sir.
okay. Sadman Shakib,
Yes, sir.
okay. Nibiruজ্জামান, Abu Sajjad Ankon,
Present, sir. Present, sir.
okay. Fahim Shakil, Mahmudul Hassan,
Present, sir.
okay. Samir Ahmed,
Yes, sir.
Khurshida Jahan,
Present, sir.
Okay, Kaushik Devdas.
There are native problem.
Okay.
Yes, sir.
Kaushik, okay. Ali Ahmed. Ali Ahmed. Rafsan, Ifat Rafsan.
Yes, sir. Present,
Okay.
sir.
Okay. Ali Ahmed present? No, Rafsan present. Okay. Priyabrata present. Fazle Rabbi. Farah Farzana.
Yes, sir.
Okay, Fazle Rabbi present.
First Rabbi.
Okay, Farah Farzana. Laila Ishrat.
Yes, sir.
Okay, Rokonujjaman.
Yes, sir.
Imam Reza.
Present, sir.
Okay, Inamul Haq.
Present, sir.
Okay, Abdullah Al Rifat.
Yes, sir.
Okay. Did anybody finished?
Sorry, to confusion arises.
No problem. Just give your solution. I'll discuss in the next class, but give your solution. If you have confusion, do it with your confusion. No problem.
Sir,
Yes.
sir, আমার নামটা মনে ডাকেনি স্যার, সুদীপ সরকার।
Sudeep, I have already called you. Okay. So those who responded, I have already given presence. Earlier I have called, right? So you are present. Those who responded, I have already given you present. Those who did not respond, I didn't call again. If you are present, you can just give your ID and name in the message box.
জি স্যার, থ্যাংক ইউ স্যার।
Okay.
স্যার আমি প্রেজেন্ট ছিলাম স্যার, মাঝে কিছুক্ষণ নেট ছিল না ওই জন্য।
Okay, okay, Miraj, then give your ID and name in the message box.
লিখেছি স্যার।
Okay. So our class time is finished, but you can upload whatever you have done. Just upload whatever you have done. No problem. Okay. So please submit the part you have already done. Okay, so
Sir, how much time left?
time is actually up, but you can take 5 or 10 minutes more. But my suggestion is whatever you have done, just upload. I will check whatever you have done.
Okay, sir.
Okay.
স্যার একটা কিছু হয়েছে স্যার।
Okay, fine. Upload that one. If you can do, go back and you can also do selective repeat. Or you can try 5 more minutes and then upload whatever you have done. Anybody? Everyone, please upload.
Minutes or now?
You can take 10 minutes. You can take 10 minutes, no problem. But you might have a class at 2. That's why I cannot force you. Okay. The class time is over, but since there is a 20-minute break, I have created a link with up to 2 p.m. Okay. So if you want, if you don't have a class at 2, or if you want, you can take up to 2 p.m. But then whatever you have done, if you want to leave now, whatever you have done, just upload and then leave.
Okay, sir.
Okay. Okay. So let me finish here, but you can upload up to 2 p.m. not after that. Okay. Thank you very much. See you in the next class.